And this opens up the possibility of a very cheap source of energy, since the fuel is basically water. Water is H2O, and that contains hydrogen. Now, deuterium, which is what you really need for the experiments that we're going to do, is 1 part in several thousand in water, but nonetheless there's an awful lot of water around in the sea, so there's plenty of deuterium. So this is a cheap and readily available source of fuel. In Europe there is a scheme called the Joint European Torus, JET, and that uses a torus. A torus is essentially a donut shape. So what they do is they get the plasma in a kind of donut shape, and they keep it suspended in space, because as I've said you can't put it in anything, by a magnetic field which causes the plasma just to continue to rotate. This distance here is about 3 meters, to give you some idea of the scale. And the temperature is 10 to the 10 billion degrees Kelvin. The plasma is made up of a mixture of deuterium and tritium. And the reaction that's going to happen is that deuterium, which is 1 proton and 1 neutron, or that can be represented chemically that way, plus tritium, which is essentially 1 proton and 2 neutrons. That is, both of these are isotopes of hydrogen. They both have 1 proton. And that's tritium, which can be represented as 3,1 hydrogen. They come together to form an alpha particle, or helium nucleus, which is 2 protons and 2 neutrons. And that's represented as 4,2 helium, plus a neutron. But you also get energy, because of the table which shows that when you take a proton out of what is essentially a hydrogen atom and put it in a helium atom, you get energy released. Now, deuterium, as we've said, is relatively easily obtainable. It's a small part of ordinary water. But tritium is not so easy to get, because tritium is radioactive and it has a half-life of 12.3 years. And so you need to renew tritium. How to do so? Well, you can get tritium if you bombard lithium with neutrons. The reaction is this one. You take a neutron and you bombard it into lithium, which has 3 protons and 3 neutrons, making a total of 6 nucleons. And that produces the tritium you require, which is this to go into here, plus helium, which you're manufacturing anyway. Where do you get the neutron from to do that? Well, it's a byproduct of this reaction. So the neutron that is released from this reaction can become the input for the reaction with the lithium. And what actually happens is that around the torus they put a lithium blanket which kind of goes right the way round the torus, so that the neutrons that come out of this plasma as a result of this equation hit the lithium blanket and produce tritium from this equation, and the tritium is then going back into this plasma and produces helium plus a neutron plus energy. There is one small downside to this process, and that is that because tritium is radioactive and it is a hydrogen isotope, it can escape. And so there is a small danger of having some radioactivity. But this risk is very much less than, say, a nuclear fission reactor, where you'll remember from my video on nuclear fission and radioactivity, the byproducts of nuclear fission reactors, plutonium and such like, often have half-lives of 25,000 years, so the waste products have to be very carefully controlled. Here the tritium has a half-life of a relatively short 12.3 years, so environmentally it's very, very much better. The idea is that the energy that is released as a consequence of this reaction, deuterium and tritium producing helium plus a neutron plus energy, that energy comes out largely in heat. That heat can drive turbines which can produce electricity. There is, however, a slight problem at the moment, and that is that, of course, in order to achieve a temperature of 10 billion degrees, you need to put energy in, usually very, very high electric currents. And the current problem is that the energy that you have to put in is greater than the energy you get out, which for a power generator is not very clever. You want to get more energy out than you have to put in. And so people are working on this to get a much more efficient system. But when they do, there will be the scope for very cheap energy with a small impact on the environment compared to other methods of energy generation.